it's like that we have to do it with the same number for the numerator and denominator.
No, you don't have to divide the numerator and denominator with the same number. Okay, basically you see what is the definition of the standard form? Rational number A and B such that A and B should not have any common divisor other than 1. The only common divisor of A and B should be 1 only, and B should not be negative. Like this 5, it could not be a negative value. It has to be positive. Okay. So you see 2 and 5, their common divisor is only 1. So you have to bring it to the simplest possible form. Right, Ifra? Okay. What about minus 14 upon 49? Minus 14 upon 49. What is its simplest form? What is the standard form?
7 2s are 14, 7 7s are 49. So minus 2 by 7.
Minus 2 upon 7. Okay.
Now, but see, minus 12 by 30, if you do it with 2, as in for both the numerator and denominator, so you get minus 6 by 15. And then if it can get more simplified by 3, isn't it? And
yeah,
you get this.
It will be divided further as well. Like
Yes.
it will be like this then. No, it will be 2 upon 5. Okay. So your answer actually came minus 6 upon 15. But as you can see, it can be divided further and taken down in the simplest form, that is minus 2 upon 5. Okay. Now, in case you have got a value like this, if the denominator is in negative, how do we make it in standard form? We simply multiply the numerator and denominator by negative 1. That is minus 1. So it becomes minus 2, and minus 7 multiplied minus 1, that becomes 7. Okay. Question number 2. Okay. We were able to solve all the questions?
Yes, sir. We just have to make the denominator same.
Okay, but I have got the your solution. Ahmed sent the solution. Okay. So make sure that you send the solution to me as well, so that I will get to check your assignment.
Okay, sir.
Okay. See question number 3. Which one was greater here?
It was minus 1 by 3.
It was minus 1 by 3. Okay. And question number 3, arrange the following rational numbers in descending order. What was your approach?
You have to make the denominator same here too.
Okay. First, we have to make the denominator same. Okay. Okay. Let's see if I have to make the denominator same of minus 2. So minus 2, with which number should I multiply it with?
First, you have to take the LCM of like all the numbers.
Yeah, first we have to take LCM of all these numbers. Okay. Including 1 as well, because the denominator of 2 is 1. That will be what? That will be 6, right? Or something else, or it has to be 18. What is the LCM here?
1 more.
Okay. Yes, the LCM is? Yes, if the LCM is 6, right?
Yes.
6, 3, 3. Okay, so it gives you 6. Okay, so we have to multiply the numerator and denominator by 6. Okay, so it becomes minus 12 upon 6. Right. The second value, its denominator is already same. Okay, it is minus 13 upon 6 and minus 8 upon 3. 8 upon minus 3, you have to write it in its standard form, that is minus 8 upon 3. Minus sign is always should always be on the numerator side. Minus 16 upon 6. Okay. So out of these four values, which one is the greatest value here?
2 by 6.
2 by 6, obviously, because it is positive. So after 2 by 6, which is the next greatest value?
Minus 12 by 6.
2 by 6 minus 12 by 6. Why? Because it is closer to 0.
Yeah.
Then minus 13 by 6 and minus 16 by 6. Okay. Now, since we are writing the values in descending order, we can write it like this as well. Right. Okay. So let's come back to our chapter. Right. So we will quickly recall the different properties. Okay, and then we will move on to solve few basic questions. I have taken few questions for you for today's class. Okay, so we will solve the questions. First, let's discuss the basics, which we will be needing to solve the questions. Okay, so you see, the first property is the closure property, which we were discussing in the earlier class, which we were discussing about in regard to whole and natural number. Right. So closure property basically says that if you perform operation on two numbers, that is whether we do addition, subtraction, multiplication, or division in any order, if the value is also same, like if I am given with two whole numbers, if I first we talk about whole number, okay. So if I have given if I am provided with two whole numbers, let's say A and B, and if A plus B is equal to C and C is also a whole number, then I say addition is following the closure property. Right. So 1 plus 2 equals to 3. We see that it is also a whole number. So for addition, closure property is applicable. For subtraction also, we will say we have already discussed this. Okay. Just in brief, we will have a look at them and come to the we will come to discuss about these properties applicability on rational number as well. Okay, what can you say about division? Is division following the closure property for whole number? Is closure property applicable on division?
It can be.
It can be. How come?
For
Like
example,
whole numbers are supposed to be in whole, they cannot be in fraction. Like if I say two whole numbers, 2 and 8, or let's take another number, because in this case we will want to understand, like it's 2 and 7. So 2 divided by 7 equals to 2 upon 7. So here it is a fraction. Okay,
no, it
but
can be and cannot be. For some cases, it can, and for some cases, it can.
that is very correct. In some cases it can be, like if I take 8 and 2, so 8 upon 2 becomes 4. Here it is applicable. But in some cases you take two numbers which are not divisible by each other, then you get a fraction. Then in that case, the closure property is not applicable over division. Similarly, if you take 1 and 0, 1 divided by 0, that is not defined. You cannot define it. Okay. Right, Ikra? You cannot divide any given number by 0. If I give you a piece of cake and I say you to divide it in 0 parts, that doesn't make sense. Right, Ikra? So division is not applicable for whole numbers. In general, we say that, but there are few exceptions. If we don't had values like this which are not divisible, and if we didn't had 0, then it would have been applicable. But we see we have got numbers which cannot be divisible. We have got 0 which gives undefined value. What about multiplication? Is it following the closure property for whole numbers?
Yes.
It is following. Okay. Like 1 multiplied 7, that gives 7. All of these are whole number. What about integers? Whole numbers, we know they are the positive numbers, positive natural numbers including 0. What about integers, in which we have got negative whole numbers as well? Okay, let's quickly check that as well. Okay, give me 2 examples of integer.
-3.
-3. -3 and
-15.
-15. Okay, so let's check this for addition. If we add these two values, what is our answer? It is -18, right?
Yes.
And -3, -15, and -18. All these three values are integers. So if we add two integer, we get an integer. Okay. So every integer is following the closure property for addition. So we say it is applicable. What about subtraction? Let's again, I will take your example. I will take example given by you. Give me 2 examples of integer. Yusufra, quick. These are the basic things, and I'm trying to get over with it very quickly, because we have to actually come to rational number. That is the main thing to discuss here.
5 and 16.
Minus 5 and
16.
16. Okay, let's subtract them. 5 minus 16, that gives you -11. So here we also see that -11 is also an integer. So we say that subtraction is following the closure property for whole numbers, for integers. Right? What about division?
Division is
Like if I divide 5 and -16, right? So it becomes a fraction here, right? If I divide 5 and -16, right?
yes.
It gives a fraction, but integers are not in the fractional form. So division is not applicable here. What about multiplication?
Multiplication is it is.
It will
Yes,
be
sir.
applicable.
Yeah, it is applicable.
What about I take 0? 0 multiplied 1?
Get 0.
0. So 0 is an integer, right? So multiplication for all the integers, it is following the closure property. So remember this thing, and it will help you in further problems as well. Okay. So these are the basic things which in almost every chapter, or in class 9th as well, you will be requiring these basic concepts. Now, if I talk about closure property, whether if it is being followed by rational number or not. Okay. Let's look at the table here. Okay. So we will see whether addition, subtraction, multiplication, and division are following the closure property for rational number or not. So let's talk about addition. Here I have taken two values, -4 upon 7 and 6 upon 11. Okay. And that gives me -2 upon 77. And we see that -2 upon 77 is also a rational number, right? So it's a yes for addition as well. Okay, so we say that rational number follows the closure property for addition, right? If what about subtraction? Here I have taken two integers, right? And the answer is 71 upon 35. So we say that closure property is being followed for subtraction also here by rational numbers, right, Ifra?
Yeah. But can I ask you something? In 3/7 and student minus, and then why did it change to plus sign?
Will you please repeat your question?
Here you see 3/7 minus 8/5, right? And then when they have taken the LCM, so they have changed the sign to. Why?
Okay, that is actually a mistake here. That is not correct. Okay, that is actually mistake here. Okay, Ifra. So what will be the value? 15 minus 56 upon 35. That will give you, yes, Ifra?
45/35.
45 by 35. How come? It will give you 41 by 30. Right, and the value has to be in negative, minus 41 upon 35. Okay, so here also we get the rational number, right? So we say that subtraction is also following the closure property for rational numbers. Okay, what about multiplication? That is very simple. Like if you see, take a few examples here. We have got two negative rational numbers, and it gives you the value 24 upon 55. So multiplication is also following the closure property. No. Will division also follow?
Fine. It's like if you try dividing it, you'll get if you take 0 as in the denominator, it's undefined.
Exactly. All the values for P and Q except 0. If you take apart from 0, if you take any integer, then we will come to conclusion that division is also following the closure property. But once you have taken the value of denominator as 0, then it will become an exception, it will not follow the closure property, right? Okay. Now moving on, let's talk about commutative property, right? Which basically says that if you are given with two integers or two whole number or two rational number, right? It could be anything. And let's say we take integers, whole number, A and B could be either integer or whole number. And if you perform any operation on these two numbers, whether we add them, whether we divide them, whether we subtract them, or whether we multiply them. And if we get a value which is same in property with A and B, meaning that if A and B is whole number, C is also a whole number, then we would say that it is following the commutative property. Is it so? Or meaning that there's actually twist over here. It has to be concerned with order of the values in which we add them, right? It's B plus A actually, right? So here I say that if I am given with two integers, A and B, okay, and I perform any operations on them, whether it be subtraction, multiplication, division, or addition, and I add them or subtract them or divide them in any order, I am changing their order basically here. And if the values nature is same, like if the answer's nature is same or the value is same, then we say that we are following the commutative property. Let's take few example and it will become clear. Okay, bro.
Yeah.
If I talk about whole number which are natural number together with 0, let's take two values here. Give me two examples of two whole number.
Uh,
Can you speak more clearly, please?
17 and 18.
17 and 18. Okay. So we see that 17 plus 18 is same as 18 plus 17, right?
Yeah.
right? That is 35. So we say addition is commutative for whole numbers, which is being followed. What about subtraction? 17 minus 18, is it same as 18 minus 17?
No, it's not.
No. Okay, because minus 1 is not same as 1. So it is not following the commutative property. What about division? Is 17 upon 18 same as 18 upon 17? No, obviously no, right? Okay. So for which number division will be commutative? For which number division will be
For
commutative?
even numbers,
For even numbers. How is it so? Even numbers are like 2 and 8. Is 2 upon 8 equal to 8 upon 2? Because
if
the
it's
first value is actually 1 upon 4 and second value is 4. My friend, and they are not equal.
or you can take it as 1 by 1
You
for
can
the
take it
both.
as 1 by 1. Okay. So if you are given with a positive value and a negative value, just their sign has to be same. The number has to be same, but the sign has to be opposite. If I take 1 and minus 1, right, Ikra? So 1 divided by minus 1 is same as minus 1 divided by 1 because both are same as minus 1, right? Because 1 upon minus 1 in its standard form is actually written as minus 1 upon 1. And the next value is already in the standard form, right?
Yes.
Again, if you take any another number apart from 1, if you take minus 8 or 8, so 1 upon minus 8 and then 8. Now, in this case, are the two values same? Is it true or false?
False.
It is false. Okay. So for 1 only, you will find that division is commutative for whole numbers. For whole numbers or for integers, we were actually discussing about integers. We actually took example of a negative number, right? So actually, we can put a cross here for integers. Okay. Now let's talk about integers. Wait a minute. Multiplication is remaining for whole number, right?
It will be the same. Like 2 into 3 is 6 and 6 into, sorry, 3 into 2 into 3 is again 6.
Exactly. So we see that multiplication is commutative for whole numbers. No need to discuss this. That is very simple. What about addition for integers like minus 3 and minus 5? So is it same as minus 5 plus minus 3? Are the two values same or not? Yes, if wrong, minus 3 plus minus 5 will give you what? Minus 8.
Minus 8. And then this will give minus 8.
It will also give you minus 8. Let's take another example. Now this time take a positive and a negative integer. Let's take positive 11. Let's take 11 and minus 7. Okay, let's check it for addition. 11 plus minus 7 is it equal to minus 7 plus 11. Just after. So 11 plus minus 7 will give you
Plus, we get 4. We get 4. And then for that, again, you'll get 4.
for this also we get 4. So we come to the conclusion that integers under addition follow the commutative property. Right, Ifra?
Yes.
So for addition it is true. Let's talk about subtraction. Okay, give me two values of integers. Two examples of integers.
6 and 9.
6 and let's take a negative value. Let's call it -9. And let's perform subtraction over them. 6 minus -9, is it same as -9 minus 6? So we see that 6 plus, it will become 6 plus 9, and it will become -9 minus 6, that will become -15. So 6 plus 9 is 15. So we can clearly see that a positive and a negative integer of same value cannot be equal because they have got different sign with them. So we come to the conclusion that subtraction is not following the commutative property under integer, right? And division we already discussed, right? Okay, like we could discuss that once more. Like if you have -3 and 8, you can clearly see that -3 upon 8 is not equal to 8 upon -3, right? That is clearly not equal. What about multiplication?
Multiplication. Yes, it is.
Yeah. -3 multiplied 7 is equal to 7 multiplied -3, right? Okay. Now, if we discuss the commutative property with respect to rational number, let's find out which operations are true, which operations follows the commutative property: addition, subtraction, multiplication, and division. Out of these four, which one is following the commutative property? Let's talk about addition. Right, from the example you can see that it seems to be correct or not. Find out the value of this -4 upon 11 plus 6 upon 11. We take the LCM, right? So it gives you -2 upon 77, right? What about this? What is the value on both the sides? This one is -2 upon 77, and this one is also -2 upon 77. So what do we conclude from this? That additions over rational numbers, for addition, we follow the commutative property, right, Ifra? Okay. What about subtraction? Let's take example of two rational numbers. Let's say 2 upon 3, okay, and -7 upon 5. Let's check whether they follow the commutative property under subtraction or not. Okay, Ifra. I'm audible to you, right?
Sorry, what?
I'm audible to you, right?
Yes, yes, you are.
Okay, okay. Now, are the values going to be same on both the sides, or is it going to be different? Let's check out. The LCM of 3 and 5 is 15. It's 15, right? Okay, and on the numerator it will be 10, right? It will be 21. Okay. So this value is what? Become 10 plus 21 upon 15. Right. So it becomes 31 upon 15, while the value on the right hand side is -31 upon 15. And we clearly see that these two values are not equal. Right, Ifra? So we come to the conclusion that subtraction is not following the commutative property in case of rational number. So it's a no. What about multiplication? That is very
Yes.
simple. Right. It is going to be a yes for rational number. What about division? Yusufra? Um, am I not audible to you properly?
You are
Okay.
audible.
Yeah. I was asking what about division? Will division be following the commutative property for rational number?
Won't be.
Like 2 upon 3 and 7 upon 5. Is 2 upon 3 divided by 7 upon 5 same as 7 upon 5 divided 2 by 3.
Yeah.
Are the values going to be the same?
No, they won't be the same. They can't even get simplified or something.
Right. They are not going to be same. So remember this thing that whenever two fractions are under division, you can actually change the division sign into a multiplication sign as I have changed here, and just reverse the places of the number given in numerator and denominator side. Like once I change the division sign into multiplication sign here, I can bring 5 from denominator to numerator side and bring 7 to the denominator position. Did you know this, Jayafra?
Reciprocal, right?
Joseph?
You did the reciprocal, right? When you put it on the other side, it becomes the reciprocal.
Exactly.
Yes.
Exactly. Right. You see, this one becomes 10 upon 21, while the another value is 21 upon 10, right? Which is not equal. So what do we say that division for commutative property, division is not following the commutative property for rational number, right? Now, we can establish conclusions for integers and whole numbers for associative property also, right? Okay. Quickly tell me, will the whole number follow the associative property or not?
Yes.
It will follow, right? What about subtraction? Associative property, what does it say? It basically says that the grouping of numbers does not matter, that we can use operations on any two numbers first and the result will be the same. Meaning that if you are given with two, let's say two whole numbers or integers or rational numbers, if you talk about whole numbers A, B, and C, so they can be added, subtracted, multiplied, or division or divided. Basically, the property says that these operations can be done on them in any order, but not all operations are applicable, right? So if we check it for addition, can we do it like this? If we take examples here for A1, for B2, and for C5, and if you put the values in the given equation, you will find that both the left hand and right hand side are going to be equal. Okay. If we do it same for subtraction, A minus B minus C, will the values be same? Let's put the same values here as well. 1 minus 2 minus 5, is it same as 1 minus 2 minus 5? If I solve this, write the values on both the sides. Is it provided the value on the left side? Hello. Ipra, am I audible?
Yes, sir.
Yes, am I audible to you?
Yes.
Yeah. Solve, find the values here. Yes, what is the value here?
It's 4 here, and the other is on right hand side, it's 5.
It's 4 here, and on the right hand side it is
5.
how come 5? Here you see you are given with -1 and -5. So -1 and -5, it becomes -6. Right?
Oh, yes.
It becomes -6. So we say that we say that integers under subtraction are not following the associative property. Or have we taken whole number, right? We have actually taken whole number 1, 2, and 5. All three values were positive. So we say that whole numbers under subtraction, they do not follow the associative property. So it's a no. Right? What about division? We'll find out for division also, whole number is not following the associative property. Right? 1 divided 2 divided 5 is not same as 1 divided 2 divided 5. Okay, it is 1 divided 2 upon 5. Let's see whether they are equal or not. Okay, 1 upon 2 divided 5. So we can write the reciprocal value of 2 upon 5. That is going to be 5 upon 2, right? And 1 upon 2 can be written like this. Any confusion in this step?
Same.
What do we observe here? It is 5 upon 2 and it is 1 upon 10. Right, Ifra? So the conclusion here is that subtraction, the conclusion here is that division for whole number is not following the associative property. Right. What about multiplication? I guess you can guess the answer here. 1 multiplied 2 multiplied 5 the same as 1 multiplied 2 under bracket and then outside is 5. 1 multiplied 10 is equal to 2 multiplied 5. Right. So multiplication for whole number is following the associative property. Okay. Right, Ifra. Okay.
Am I audible, sir?
You're audible, but your voice is very low. Okay. So if you were to find this for that for rational numbers, if you were to find whether these four operations are applicable under the associative property for rational numbers or not, you will find that if you take example of addition for rational number, okay, you will find that you will find that where was I? Actually talking about associative property for rational numbers, right? So you will find that addition is actually applicable for rational numbers under associative property. Okay, this one I have left. You have to actually do it as your assignment. Okay, whether integer is following the associative property under addition, subtraction, division, and multiplication or not. That will be part of your assignment. Okay. For now, if I talk about rational number, okay, let's talk about rational number. Okay, if we talk about addition, I take two rational numbers, I take three rational numbers, 1 upon 2, 5 upon 7, and 8 upon 3. Can we add them in any order? Yeah, we can add them in any order and the answer is going to be the same, right? Yes, Ifra.
Yes, sir.
We see that addition for rational number is following the associative property. But what about subtraction? Can we subtract them in any order, like 1 upon 2? Can we subtract them in any order? 1 upon 2 minus 5 upon 7 under bracket minus 8 upon 3. We can't do this, right? So you will find out that rational number is not following the associative property. Further, you will also find out that for division also, it is not following the associative property. Okay.